Hey guys, this is Pranoy. Welcome to my channel where we solve interesting math problems every single week. And if you are new to the channel, please consider subscribing and we'll have fun solving more problems together. Alright, let's get into today's problem, which is an interesting one based on the concept of shortest path. Here we are given a rectangular grid made up of 20 small squares, each having a side of 1 unit. And we are required to find the number of shortest paths along the edges of this grid from point A to point B. So visualize our grid. And there can be many number of shortest paths that takes us from point A to point B. For simplicity, let's consider the top right hand corner of this grid as point C. And in the first case, we want to go from point A to point B by taking the path ACB, which is nothing but path AC, which is moving us from left to right, and path CB, moving from top to bottom. Path AC can be further decomposed into 5 horizontal steps, 1, 2, 3, 4, 5, and path CB can be rewritten as 4 vertical steps, 1, 2, 3, 4, which gives us 5 horizontal steps and 4 vertical steps. Now let's say we are feeling more adventurous and we want to take a more convoluted path from point A to point B via the points X, Y, and Z. So this is nothing but path X, Y, Z, B, which is path AX plus path XY plus path YZ, and finally path ZB, which we can rewrite as 2 horizontal steps followed by 2 vertical steps followed by 3 horizontal steps and finally followed by 2 vertical steps. And if we rearrange what we arrived at just now, we get 5 horizontal steps and 4 vertical steps, which, if you recall before, is the same as path ACB. So now if we generalize the problem in the context of this particular grid, we know that going from point A to point B requires us to take 5 horizontal steps and 4 vertical steps. So all possible shortest paths from A to B must be a combination of 5 horizontal steps and 4 vertical steps, which can be neatly reframed as a problem that we often encounter in permutation and combination, which is how many words of 9 letters can be made using 5 H's and 4 V's. And the answer to that is factorial 9 divided by factorial 5 times factorial 4, which gives us 126. So now if we go back to our original problem, the number of shortest paths along the edges of the grid from A to B is 126. And that's your answer. Congratulations, you solved it. Before we end the video, let me give you the general solution to this kind of a problem. Whenever we encounter a grid of any size that has m horizontal steps and n vertical steps, the general solution for the number of shortest paths from point A to point B is factorial m plus n divided by factorial m times factorial n. And that's it. Thanks for watching till the end, and I'll see you in the next one.